There are various methods of solving simultaneous equations, and one of the methods is the elimination method, where we eliminate one of the variables and then try and find the value of the other variable and then plug in that value and find the value of the other variable also. If you find this method a little confusing and you want to learn all about it, please jump into the video right now. Hey guys, my name is Vikas Sharma and I welcome you all on behalf of Exponent to Success. Exponent to Success is an initiative that adds an exponent to your learning curve. If you are new to this channel, I would suggest that you subscribe to the channel right now so that you don't miss out on any of our future great content. Like I said earlier, there are various methods of solving simultaneous equations or linear equations in two variables. And to solve these equations, we have already done two of the methods. One was the graphical method and other was the substitution method of solving simultaneous equations. And in case you haven't gone through those videos yet, the video links are given right on the top right corner of your screen. Just click on those and watch those videos again. And if you have, well, we are here to learn another method, which is the elimination method. Now I'm sure you must be thinking, why are there so many methods and why should I do the elimination method? Why can't I do just by the graphical method or by the table of values method or by the substitution method? Well, I told you there were some drawbacks involved in the graphical method and then the table of values method, but yes, you can find your answer through the substitution method, but sometimes it happens that the elimination method works out to be easier. So if you want to make your job easier and you want to learn what are the steps involved in this, and stay till the end of the video, because at the end I'm going to give you very simple steps on what all to do, and all the steps are mentioned at the end of the video, so watch right till the end. So here I've got an equation for you, which is 4a plus 7b is equal to 27 and 4a minus 7b is equal to 13. Now like we did in the video of substitution method, let me give a name to each of these equations. Let me call this equation number 1 and let me call this equation number 2. Now here this is a very simple kind of equations where it is very easy to solve. So just by looking at these variables, you know that the coefficients of a are 4 and 4, the coefficients of b's are 7 and negative 7, and the constant terms are 27 and 13. Now if I add these two equations, I can add or subtract these two equations, and if I do that, well, obviously plus 7b and minus 7b, they get cancelled out. So I'm going to just add these equations together and I say add equation 1 and equation 2. I'll use the vertical method here. So when I add 4a plus 4a, I get 8a, and 7b minus 7b or positive 7b, and I add to that a negative 7b, it becomes 0. So I don't need to write that, or I can just say plus or minus 0 or whatever, since 0 is nothing, so I don't even need to write that. And well, don't miss out on this, because it is very important that you when you're adding both these equations together, you don't only add only the left hand sides, you have to add the right hand sides as well. So I'm adding the constant terms also. So 27 plus 13 gives me 40. So what I am left with is 8a is equal to 40. Dividing both sides of the equation by 8, 8 and 8 get cancelled here, and here 8 goes into 40 5 times. So I've got the answer a is equal to 5. Now of course that is a solution, that a is equal to 5, but that is not the complete solution, because when we are solving for a simultaneous equations, when we are solving a system of equations, we need to find both the variables and not just one variable. Now once I've got the value of a, what I can do is I can substitute this value or plug in this value in any of the two equations that we have, and we can then solve for b and find the value of the other variable. So what I'm going to do is I'm going to plug it into equation number 1, and the reason why I do that is because negative signs always may cause a little bit of confusion, though they shouldn't, but still it is easier with addition. So I'll plug it into equation number 1 and let me see what I get. So 4 times a, so instead of a I will use the value of a now. So the value of a is 5, so I say 4 times 5 plus 7b is equal to 27, or 4 times 5 we know is 20. 20 plus 7b should give us 27. I subtract 20 from both the sides, so I'm left with 7b on the left hand side and 27 minus 20 on the right hand side. So 27 minus 20 gives me 7, and then I divide both the sides by 7, and 7 gets cancelled, and this also 7 gets cancelled. So what I'm left with is b is equal to 1. Now this is the solution that we have, so we can just leave it here, or if we want to double check that we have done it correctly or not, what we can do is we can plug in these values of a and b back into any one of the equations above and see whether it satisfies the equation or not. Okay, so let's do that. Let's plug in these values of a is equal to 5. I can also write this as an ordered pair or as a point on the Cartesian plane. So let me just write it that the solution is 5 1. But the value of a is 5 and the value of b is 1. Now plug in this value into any one of the equations now. So let me plug into equation number 2 to check whether we are correct or not. So it's 4 times a, and a we know is equal to 5, so 4 times 5 minus 7 times b, and b we have found this is equal to 1, that should give me 13. Okay, 4 times 5 is 20, and 7 times 1 is 7, that should give me 13, and yes, 20 minus 7 is 13, so 13 is equal to 13, which means our solution that we found out, the ordered pair 5 1, that is correct. So that's how you solve simultaneous equations. Let's try and do this where it's 3a minus 6b is equal to 12 and 4b minus 2a is equal to 8. Now here if we see, there is one little problem here. The problem is that the a term is here, and here the a term is written here, the b term is here, and here the b is here. Well, this looks quite a mess. So the first step that I'm going to do is I'm going to rearrange these equations in a proper manner. Let me do that. Okay, so I'll put all the a's together. So I do 3a minus 6b is equal to 12, and I'll bring the a term in front now. So it's negative 2a plus 4b. Take care of the signs when you're changing. The signs should go along with the numbers of the variables. So that should give me negative 8. So that's the two equations that we have, and now let me name the two equations 1 and 2. Now what can we add? Can we add the two equations to cancel out the terms, to cancel out any of the variables like we did in the first question? Well, the coefficient of a is 3 and here it's negative 2, so obviously they are not the same, so we can't add the equations together. Here it's negative 6 and here it is 4. Again, they are not the same coefficient, so we can't add them together. So that brings us to a little bit of problem. Well, that problem can easily be managed, because what I'm going to do is I'm going to multiply both equations by some number so that we can get the same coefficient. Well, let's target for b then, that if we want to eliminate b, what can we do? What we'll do is we have got two numbers there, 6 and 4, and we find out the LCM of that. So LCM of 6 and 4 is how much? 12. So now we want to make both the coefficients of b equal to 12. What I'm going to do is 6 times 2 is 12, so I'm going to multiply equation number 1 by 2, and 4 times 3 is 12, so I'm going to multiply equation number 2 by the number 3. And when I'm doing that, make sure that you do that to both sides of the equation. I'm going to rewrite these equations again. So I get 2 times 3a is 6a, and 2 times negative 6 is negative 12b, and 2 times 12 is 24, don't forget that. Then coming to the second equation, I need to multiply both sides by 3. So 3 times negative 2 is negative 6a. 4 times 3 is 12, so we get positive 12b, and negative 8 times 3 is negative 24. So okay, now we see that there's one negative b and one positive b, so let's add these equations together, and what we get is 6 times a minus 6 times a, so that becomes 0. So a has also been eliminated, and we get negative 12b and positive 12b, that again gives me 0, and 24 minus 24 again gives me 0. So what I'm left with is, it's hilarious, what I'm left with is just 0 is equal to 0. Now that doesn't give me any solution, that doesn't give me the value of a, that doesn't give me the value of b. So what do we do? Well, as I explained in the last video, there's nothing to worry about, because whenever we get a number like this where 0 is equal to 0, or say 1 is equal to 1, or say 5 is equal to 5, or any number which is equal to number, and the statement that we get or the equation that we get is true, it's true in all these three cases. So if it's a true equation, that means that there are infinite solutions. So one solution does not exist on this for these set of equations, and there are infinite solutions. Now even if you draw a graph of these equations, what you'll find is that when you draw a graph, and if you have a line like this and you draw the graph for the second equation also, you'll find that line coincides on the first line. And when it coincides completely on the first line, what happens is that each point on that line is a solution for both those equations, because both the lines are falling on the same points. So these set of equations have got infinite solutions. And just as a note, if I tell you that even if we get even if both the variables are eliminated, and we get something like 9 is equal to 0, or say 1 is equal to 3, or say 6 is equal to 13. Now whatever we get, and this statement is false, then that just means that there is no solution, or you can say that the solution does not exist. So just remember, if we can eliminate the variable and find out the value of both the variables, then there is only one solution to the equation. If we get a statement where both the variables are eliminated and the numbers that we get, they form a true statement, then there are infinite solutions. And when they form a false statement and both the variables are eliminated, then we can say that the solution to both the equations does not exist. There is no solution that can satisfy both these equations at the same time. Okay. So how about doing some word problems now? We have done a lot of equations being given to us. How about reading some word problems and making the equations for ourselves. Okay, so the first question that we have here is that Sam bought 3 tables and 4 chairs which cost him $370. If instead he were to buy 2 tables and 3 chairs, it would have cost him $260. Find the cost of 1 table and 1 chair. Well, how can I do this? Now, the equations were given to me earlier, but in this case the equations are not given to me. What can I do? Well, I can read the question and try and form the equation, or we can say that let the cost of a table be $t. Okay, so T is for table, and we'll say let the cost of a chair be $C. So table T is for table and C is for chair. So the equation that we get after reading the question again, that Sam he bought 3 tables and 4 chairs. So the cost of 1 table, if it is $t, the cost of 3 tables would be 3t. And if we add to that the cost of 4 chairs, which means 4c, it costed him a total of $370, right? And then it says that if instead he were to buy 2 tables, which means 2t, and 3 chairs, so plus 3c, it would have cost him only $260. Now what can we do? Well, there are a couple of options that we have. I'll put all the options in front of you, and then we'll choose what seems to be the best. So one is that to eliminate, all the coefficients are different, so I can't do anything. If I want to eliminate the variable c, I've got 4 and 3 as the coefficients of c's. Now the LCM of 3 and 4 is 12. So if we want to make both the variables as 12, I will have to, so let me give the names first. Let this be equation number 1, let this be equation number 2, and what we can do to these equations is the choices that we have: multiply 1 by 3, since we want to make the c as 12, and 2 by 4. That is one of the choices that we have, but that also won't solve it, because when we add the two equations together it won't give us a 0. So we will make one of these numbers as negative. So multiply 1 by 3 and 2 by negative 4. If we do that, then we'll get negative 12c, and then when we add those equations together, it will eliminate the variable. So we can either do that, or we can just do the same thing again, that multiply 1 by 3 and 2 by 4. But now instead of adding the two equations, we will subtract the equations. So add or subtract to eliminate, right? So these are the options available in front of us. So what I'm going to do is I multiply this equation by 3 and this equation by negative 4. So when I do that, I get 3t multiplied by 3, that gives me 9t, and 4c multiplied by 3 gives me 12c, and 370 multiplied by 3 gives me 1110. And the second thing that we have is we multiplying the second equation by -4. So 2t multiplied by -4 gives me -8t. 3c multiplied by -4 gives me -12c, and 260 multiplied by -4 gives me one negative, because there's a negative sign attached to it, so -1040. So now I'm going to add these two equations together and let's see what we have got. So 9t minus 8t gives me only 1t, or I can just say t, and 12c and minus 12c, they get cancelled out, and here 1110 minus 1040, that gives me 70. So now we have found that t is equal to 70. That means the cost of one table is $70. So that's the solution. I can highlight that. And then once we have found this, I'll substitute this into any of this equation, or plug in this value of t into any of the equations that we have. What do you want to do? I can either plug it into 1 or plug it into 2, but since the equation number 2 has got smaller numbers, I'll plug it into 2 instead. So I say substituting t is equal to 70 in equation number 2, I get 2 times 70 plus 3c, that gives me 260. 2 times 70 is 140, and plus 3c, that should give me 260. Then subtracting 140 from both sides of the equation, I get 3c is equal to 260 minus 140, so that gives me 120. And then I divide both sides of the equation by 3, because we want the value of c alone and not 3c. So the 3 and 3 get cancelled here, and 3 goes into 120 40 times, so I get the value of c as 40. So that's a solution. We can again highlight this. So the cost of one table is $40, and the cost of one table is $70, and the cost of one chair is $40. Now if we substitute back into the equation, into any one of the equations, it should satisfy the equation. So let's substitute in equation number 1 first. So if the cost of t is 70, that means 3 times t should give me 210, and 4 times 40 should give me 160. So 210 plus 160, if I were to add those together, I get 370, and yes, that does satisfy our equation. That does give us the right answer. Let's go over another question that I have and try and go over this very quickly. Because we have already learned how to solve the equation, so it's just a matter of we'll run through the questions now very quickly. So the question that we have is that Pompey has only 50 cents and $1 coins in his piggy bank. If in all he has 50 coins totaling $41, find the number of coins of each type he has. Let's say the number of 50 cents coins be what should I say? Okay, let's take P and Q, say BP, and let's say the number of $1 coins be Q. Now we know that both the coins, he has a total of 50 coins, so we know that P plus Q is equal to 50, right? And then it also says that they total up to $41, so we'll have to find the value. So therefore the value of 50-cent coins is equal to, so if there are p coins and each coin is worth 50 cents, so if I would want to do that in dollars, then 50 cents is equal to $0.5. So I can say it is 0.5p, that many dollars, and therefore the value of $1 coins is equal to, so there are q coins and each coin is $1, so that means it will be q dollars. So there goes our equation. The second equation that we have is 0.5p plus q, that gives us 41. So again, let this be equation number 1, let this be equation number 2. To eliminate the variables, what we need to do is we'll have to subtract both the equations, or we can multiply equation number 2 or equation number 1 by -1 to make the variables negative, but I think let us just subtract the equation. So when we do a vertical subtraction, the signs change, so this becomes, all of these becomes negative. So p minus 0.5p, that gives me 0.5p. q minus q gives me 0, so I don't need to write that, and 50 minus 41 gives me 9. Therefore dividing both sides by 0.5, the 0.5 here, they get cancelled, and I get p is equal to 9 upon 0.5. I can get rid of the decimal by multiplying by 10. So it's basically because 0.5 is 5 by 10, so the 10 goes on top, and then 5 goes into 10 two times, so I get the value of p as 18. So that is one solution. So I say number of 50-cent coins is equal to 18. And then let's try and find the value of q. So again we can substitute it in any of the equations that we have, but let's substitute it in one. So we say p plus q is equal to 50. That's the equation. And p we know is 18, so 18 plus q, that should give me 50, and when I subtract both sides by 18, I'm left with q is equal to 50 minus 18, that gives me 32. Or in fact, let me write it as number of $1 coins is equal to 32, and that's our solution. So we'll highlight that also. So how about writing the steps very quickly for you. So the first step is to rearrange the equation and write it in a proper manner where all variables, each of the variables come in a proper order. So if it's x and y and then the constant, so in the second equation also it should be x and y and then the constant. You can't have y and the constant and then x, or constant and then y and then x. So you can just have all of both the equations written in the same order. Once we have done that, the second step is to figure out which variable can be eliminated, which one will be the easiest to eliminate, and then do we need to multiply any equations by any number. So the second step we would say is multiply each of the equations if required by some number to make the coefficients of one of the variables as equal. And the third step we can then say is that if the equations, if the coefficients are now opposites of each other, that means if we have got one positive and one negative, we can just add the equations together, and if they're not opposite, if they're both positive or both negative, then we can subtract one equation from the other. So the third step would be add or subtract one equation from the other. Now what we are left with is a linear equation in one variable, so the fourth step would be solve for the variable as a linear equation is solved. Fifth step, once we have found the value of one variable, we plug it back into any of the equations. So the fifth step would be plug in the value of the variable in any of the two equations. And the sixth step would be, so the sixth step would be solve the equation to find the value of the other variable. So that gives your answer. And once again, if you've got two different numbers, if you've got the value of x and value of y, you have got one solution to the equation, to the set of equations. If you've got just two numbers on both the sides, 0 and 0 or 1 and 1 or 9 and 9, then it has got infinite solutions. And if you get something like 5 is equal to 9 or 4 is equal to 12, then it means it has got no solutions, because that statement isn't true. So there are no solutions to that. So I'm sure you must have understood a lot by now, and in case you still have any questions remaining to the elimination method of solving simultaneous equations or the system of equations, you can just leave it in the comment section. What do you think? Was it easy for you? Did the video help you really, or was it just a waste of your time? So I do want to hear your comments. Please leave your comments right now in the comment section below, and if you haven't subscribed to the channel as yet, subscribe channel by clicking the subscribe button here, and please click on the bell icon also, so that you don't miss out on any future content. Do not forget to like and share the video with your friends. Watch these videos on the left. Take care. God bless.